Okay, I would say that these last two problems are optional if you want some more help. We are going to choose the easier formula and then solve. So if Andrea is self-employed and wishes to accumulate a retirement fund of $250,000, how much should she deposit each month into an account that pays interest at the rate of 4.5% per year, compounded monthly, in order to reach her goal for retirement 25 years from now? Okay, so I immediately see the question is how much should she deposit? So we are looking for that periodic deposit because she's also doing it each month. So M equals 12. We know that she eventually, so in the future, her S value is $250,000. R is 0.045 and time is 25 years. So I'm going to use the sinking fund formula on this one because I find that one to be easier. So I'm going to set this up as R equals a giant fraction, parentheses on the top, 0.045 over 12, close those up, times, still on the top, $250,000. And then going to the bottom of the big fraction, set up a giant bracket, inside that a parenthesis. Inside that parenthesis, we're going to do 1 plus 0.045 over 12, close it up, to the 12 times 25 power, and I'm back down on the main level, minus 1, close up the giant bracket. Okay, so I'm going to do this in stages in my calculator. I'm going to start with 0.045 times, oops, not times, divided by, go back, divided by 12, times, still on the top, $250,000. So on the top I get 937.5, and then I'm going to divide by parenthesis, parenthesis. Inside the second smaller parenthesis we're going to do 1 plus, and then the fraction 0.045 divided by 12, and close that one up, all to the 12 times 25 power, 25 power, and then back down to the main level to do a minus 1, and close it up with a last parenthesis. This should give us our final answer, $452.08. So that would be her monthly payment amount. Okay, number 6 says, if Jackson deposits $100 at the end of each month. So I immediately notice that this one gives me the big R value. And at the end of each month says that little m is 12. So these things will start sticking out to you the further that you go in these. And into a savings account earning 3.5% interest, so little r is 0.035, compounded also monthly, so again, those things always match with an annuity or a sinking fund. How much will he have in this account after 6 years? So time is 6, and we want to know how much will he have in the account, and well, that's the future value, big S. So in this case, I'm going to use the future value annuity formula. So solve for S. S equals 100 times giant bracket with a fraction inside. On the top of that fraction, we do parentheses 1 plus, then the fraction 0.035 over 12, close up that parenthesis, to the 12.6 power. It's m times t, and then don't forget the minus 1 back on the main level up there, all over that same fraction of 0.035 over 12 in the denominator. Okay, so show me that step, and then the rest of it you are welcome to do in your calculator. I'm going to start on the inside there. I'm going to do parentheses 1 plus 0.035 divided by 12, close that up, and take that to the 12 times 6 power. And I like to stop there and go ahead and hit enter. It's a personal preference. Then I like to do my minus 1 and hit enter. And then divide by parentheses, 0.0335 divided by 12. Close up those parentheses so that we divide by all of that. And finally, multiply by 100. So it looks like the final answer here is $7,998.89. So that's how much he will eventually in the future have in that account. And you just want to do a lot of practice back and forth with recognizing the different variables and recognizing if you're finding a future amount, if you're finding a present amount, or if you're finding that big R periodic payment amount. Those are the big key things to recognize to get these correct.